Hello and good morning. As you can see, the sun is just rising here, and this is going to be about how we did this little thingy down here. You can watch that video so you know what we are talking about. And the idea was that normally when you see something like a gate done this way, it's done with falling sand or gravel because it's easy to do in terms of you just you have this pushed up as it is closed and you can't get through it, and then when you switch it off, this will automatically fall down with the pistons, so you don't have to worry about retracting or anything. And you can do that very easily with a little setup we'll come around to. So basically what you're doing here is that you have a sticky piston here and you have a normal piston here. You could have a sticky piston here, I suppose. Wouldn't really matter. So what you do is that you turn on A and then B, and when you want to go back you turn off B and then A, so you have an ABBA. And this little thingy here, if you power into here, you have a delay here, so this one will turn off and it can go through here because the repeater points that way, and then this one will turn off. Let's see, like that, and now they're turned off and then on again. And as you can see, because of the way that the repeaters are set up, this works just like that, ABBA. If this like that, like off, off, then you want that to be on, 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 on. So what it basically is, it's basically a, well, I'd like to call it a digital representation of a stack, as opposed to a queue. If you look at the forums for the Minecraft or the wiki or something, I think they normally refer to this as an, I don't know if they actually they call it an ABBA switch, but if you would pronounce that, it would call an ABBA switch, and I don't know, because since I'm from Scandinavia, I would just think about breaking into song or something like that. And if you don't know who ABBA is, then I suppose you are of the younger viewers. Anyways, we can extend this if we wanted to. Just wanted to show it. It's not really anything to do with the gate. Actually, we will come to that. Whoa! Come on. So if we have A, B, C, D, A, B, C, D, oh, C, D, B, A. So yeah. And you could just wire this up here. Let's check this out. See if it actually works with a switch like that. And yeah, it does, as you can see. The problem is, if you want to make a gate and you're using this setup, you're stuck with falling sand here. I don't know if you do it like this with gravel, if that would actually turn into flint if you do it with a piston like that. or if it has to be actually digged, or you know, the old trick by setting a torch underneath. So the reason is, well, sorry, got kind of sidetracked there. The thing is that if you want to make it like this, there's a couple of things that you need to be aware of. First of all, how do pistons contract, and what is the properties of this sticky piston? Because you cannot pull back the piston up here with this sticky piston when this is on, when it's flicked on like this. So there's a couple of things that you need to be aware of when you work with this. And this you have here is basically it's basically the setup like this. I just, you know, see you have the floor here and what's going down underneath. And let's see here. Yeah. So basically what you want to do is you want to, I'll show you. When I do like flick it here, as you can see, it pushes up 2 and then it contracts down and it leaves this one up in the air. And it does that automatically by just pushing those up 2. So what we need to do over here is that we need to have this block being pushed up 2, and so we need 2 pistons, and then we need to get it down again. So both of these are sticky pistons. Right. And if I flick this one, as you can see, the wiring here is done in such a way that when I flick this one on, it will turn both these on. So I have, by the simple flick of a switch here, so to speak, I have this one up 2 in the air. And the reason I'm doing this is because it will allow me to work with a very nice pattern later on, and we'll get to that. So now that I have flicked this on and pushed it 2 up, I turn it back off again. And as you can see, because it does it like this piston contracts and pulls down the stone. But because this one is actually still up in the air, so this one does not grab this one here. So I want to take this one and grab it and pull it back down. So I have this here wiring that allows me to do just that. We grab it and we pull it down. Now, as you can see, the way that these pistons work, it will leave this one up in the air. So as a final bit, we need to take this here, wire it into here, and get up and grab it. So what we're actually doing here is we are doing an A, B, B, and C, C. So A, B, B, C, C. And that's why, because if we didn't have this firing off at both at the same time, it will get a bit more complicated. So with this setup here, where this comes into play, it allows us for this really nice pattern here with A, B, B, C, C. Now obviously that will not work with this ABBA switch, but if we just really simple need to power something on and off, then the next on and off, and then the next on and off, we can just do it with repeaters. Really. And I can see I've wired this up just a tad too much to begin with. Let's just get rid of some of this now so we can look at it. Get rid of that. Here and here. Yeah. So if I push here, so we want to A, B, B, C, C, or we want to turn this on, off, then this on, off, and then this on, off. Let's see. On, off, on, off, on, off. And that's actually just done with repeaters. You see, so you have one more repeater here than you have here in order to ensure that this one gets fired off the 4 ticks later than that one. And if you wanted to be a bit more consistent, I suppose you could put in another repeater here. But I mean, that's up to whatever you want to decide, however you want to design this one, really. So in theory, we just need to wire this one up to our contraption here. Now, what's interesting here actually is that, as you can see, this one is inverted, so we need to invert this one. And these two isn't. So let's like that, and like that. Now you can see, because I've pulled them in different ways, this one it looks a bit weird. So let's see if we can reset it by just pushing the switch here. Certainly. So now it's actually would be open. And then we can push it, or open or closed. So this one actually does what we want. It pushes up to, then contracts down, like that. And if we look at the actual gate over here, the part we have now is when this one gets pushed up by 2 and then gets pulled back down, like that. Where are we? Here. And as if you look at it, you can extend this in the direction that you want to, and you can extend it for how wide you want your gate to be. It doesn't really matter. The only thing that you might be wanted to be aware of is, of course, the normal 15 or whatever it is blocks that the redstone can travel before running out of power. So, but basically, if you wire them up like this, and then just really simple make this with the repeaters in order to ensure that you have your AA, BB, CC firing in that order. As you can see over here, you actually have your opening mechanism for the gate. And then you might be thinking about, what about closing? And I'll get to that. But the thing is about closing is that you actually just have to push whatever height your piston, whatever height your gate is, down. You don't actually have to contract or anything, have to grab something that will be up in the air. So that's basically a really simple thing to do. So this is actually the hard part. Now, as you can see, this is worked by a button. And you might want to think about, but hey, you don't work this by a button, you work by a lever over there. And if you do put in a lever, it does get kind of a bit more tricky because, well, let's see, do we have a lever? Yeah, I have a lever here. Because I would want to put it on and off in the correct amount of time that this one works in. And you can't actually be sure, and you don't want to do that really, no, because you wanted to say, yeah, well, I wanted to have my gate closed like that, and then I want to go down there, and then I want it to be open. Problem is then, how do you do that? I mean, really, because what you really need is that you need to make this little setup here. This little setup is basically a pulsar. What that means is it sends out a pulse on whenever the input changes a certain state. You have two kind of pulsars. You have one that might send out a pulse when the current, so to speak, goes from high to low, or you can have a pulsar that changes state when the current go from low to high. So that's what we want to do here, is that when we in theory start off like here in our off position, I want our pulsar to fire when our current goes from low, that is off here, to high, so on here. And we can see this one down here. Whenever this one goes from off to on, the piston down here will fire. Right? When it goes from on to off, nothing happens down here. So so it sends out a pulse when we turn on the system, but it doesn't send out a pulse when we turn off the system. So that's what we wanted to build down here, because otherwise, it would just send out a pulse no matter what. When the gate like this is opened, it would try to open it again then when we did that like that. And we don't want that to happen, because we want it to actually close and not try to open when we push the lever up. We only want to open it when we push the lever down. So that is actually what we do have here. So this little setup here fires off when we push the lever down. Yeah. And then we might be looking at a little problem, as you can see. Why is that? And the simple thing is that if your pistons fire faster than the one tick with this pulse, it has not enough time to actually pull back the other pistons. If you have something like a rapid let's just suppose we could just build that to show you what I'm talking about here. So you can see this one here is firing off in an awful fast. And is that no, that's not a sticky piston. Let's get a sticky piston like that. And if I put this here, as you can see, it doesn't always grab this one because it's just too fast for it to grab. And it's noisy, so we just take this one down. Right, so it seems that our little pulsar here is actually doing this tad too fast. So let's just try and delay it a bit. See what happens. See if we can reset this. Oh my god, did you just look at that? Let's try that again. So we flick it up and we don't want anything to happen, so that works. Now, click it down, we want it to open. Yeah, just like that. That's how you open the gate. And as I said, the actual closing of the gate is pretty simple because you just need to push it down, really. You have the pistons up at the top here. Let's see if I can get a look. Like this. And they're basically just pushing down on whatever is underneath it here. So let's just take this one here, I think. Yeah. So they just fire in terms of that in order to push down the whatever is beneath them. I have a little setup similar here, as you can see. And if we connect that, so basically when I am at this point, that would be the point where the gate is closed. In theory, it doesn't really matter when the gate is closed whether or not these are extended or not, but that's just this will work. And then I flick this button, the gate should open, and when the gate opens, because you can't push when these are extended. So when these push up, we need to make sure these are off, but because of all the electronics we already have in place here, it shouldn't really be a problem. If it is a problem, it's just a matter of actually plopping down a couple of delays or something like that. So anyways, what we wanted to do now, when I pull the lever down, I want this to turn off, and then I want this to go ahead and do its thing. So these are off, and then this does whatever it is it does, and it's perfect. And when I turn this one off, I don't want anything to happen here. That's why I have my pulsar. I just want these to be fired. Like that. And that's basically it. There's not anything else to it. That's just what you, as I said, the thing that's hard here is to make sure that you get this AABBCC down, because if you do not have this A wired like this, like I have here, you're going to look at, you need to fire them off like something like A, B, C, no, A, B, B, C, C, and A, or something like that. I can't remember, and it's not really important. The thing about it is that you don't have this really neat pattern like A, B, B, C, C, or if it was your normal style over here where you have an A, B, B, A, or A, B, C, D, D, C, B, A. I mean, these nice patterns. So that's the reason why this is wired the way it is. As you can see, we have one coming up here, we have this one down here, and then we have the last one over here, which are inverted to control the last bit here. Then we have the delays in order to make sure that we fire them like this, which is just these really simple delays. And then to extend it a bit more, we have the pulsar here, so that we only fire it when we flick this bad boy down. And then it's just a matter of making sure when we flick this bad boy up, this one gets powered. And that's what happens down here. So this one here is connected inside here where it shoots up, and make sure that when I flick the lever off, these get fired in order to close the gate. And likewise down under. No pun intended. But our lever is coming down from here. Oh, yeah. Oh, yeah, sorry. Then the pulsar here, and then we basically just have the different delays in order to make sure we are setting them off in the correct. And as you can see, that's how I'm extending these. So in theory, I could have made this as long as I wanted to. And since I'm only pushing them up 2, if I really wanted to, I could have made this, let's say, 5 high. I would just have needed this setup to be 5 high. So it might be a tad tall, but it's independent, so to speak, of whatever happens down there. The only thing that it needs to be sure of is that there's nothing being powered down here, and that's why we made the pulsar, so it doesn't get any power when I flick this one up, and it could have pushed this one down. So that's just about it. Yeah, I don't think there's really much more to it. I mean, as I said, you could have these as high as you wanted them to when you needed to push down the gate. The thing that gets a little bit more tricky is that if you want to make your opening actually push up more. So let's say if you wanted, instead of having to push it up 2, you wanted to have it push it up 4. I might be looking at making a little bit of something like that. At least I'm thinking it would be easier to have it push it up 4 than 3 in multiples of 2. That's my initial feeling, at least. But otherwise, this is just the small bits, the closing mechanism, the pulsar that makes sure that we only fire this one when we actually need to, the little delays, and the opening mechanism, so to speak. So thank you for watching, and give me some feedback. Bye.